In this lesson, we're going to talk about situations where you are solving exponential equations, but the base on both sides of your equation is not the same. The sample problem we're going to use here is 2 to the power of x is equal to 32. Right now we can't solve because 2 and 32 are not the same base. However, I happen to know that 32 is the same thing as 2 to the power of 5. 32 is 2 to the power of 5. So I can change my equation up here. I'm going to add another equal sign and I can say 2 to the power of 5. We can then change the problem to be nice and easy. I can just ignore my 32 in the middle here. And look, we've got the exact same problem as we had in our previous lesson. 2 to the power of x equals 2 to the power of 5. Well, I can jump straight to the answer of x is equal to 5. So the trick with these questions is that you have this additional middle step where you need to change a number into something with the same base plus an exponent. Now, because having your exponents memorized is a lot, I have included this reference table here that is very easy for you to use. For example, let's say I was looking for, I needed a base of 2 and I needed my number to be 32. Well, I'm going to go 2 and I'm going to look across the table for my number. Now 32 hasn't been included here, that's just an example. But let's say I needed a base of 3 and I needed the number to be 1 over 9. Well, in order to get 1 over 9, that would be 3 to the power of negative 2. We'll use this table as we work through some basic problems. Solve for x. 3 to the power of x is equal to 27. So I need to look for a base of 3 that equals to 27. So base of 3 equals to 27. Well, that's an exponent of 3. So this problem is 3 to the power of x equals 3 to the power of 3. 27 is the same thing as 3 to the power of 3. We can jump right ahead. We can say, well, that must mean then that x is equal to 3, now that our bases are the same. Let's do another one. 6 to the power of x is equal to 36. I need a base of 6, so I'm going to start across the 6 column or the 6 row here, and I'm looking until I see 36, and here it is. 6 to the power of 2 gives me 36. So I can change this to be 6 to the power of 2. I can then solve nice and easy. X must be equal to 2. Let's do one where we have a fraction. 4 to the power of x is equal to 1 over 16. I look at a base of 4 and I need to find 1 over 16. Well, in order to get 1 over 16, I need an exponent of negative 2. So 4 to the power of x, instead of 1 over 16, I can write 4 to the power of negative 2. Therefore, x must be equal to negative 2. 3 more examples. 2 to the power of x is equal to 1 over 2. I need to rewrite this problem, so I'm going to go base of 2. I need to find 1 over 2. That's with an exponent of negative 1. So 2 to the power of x is equal to 2 to the power of negative 1. And therefore this implies that x is equal to negative 1. Okay, let's do 5 to the power of x is equal to 5. So I need to find 5 to the power of 1 gives me 5. So I'm going to rewrite this as 5 to the power of 1. And now I can easily see x is equal to 1. In our last problem here, we actually need to find something that has the exact same base. All of these, it was easy because we needed to find it for the second side of our equation. not the first side, but here we have a bit of a situation. I need to find a number that has 243 and it has 81. I know that that is going to be the number 9.